Sign in now. Naveen, now voice okay now? Naveen?
Yes, sir. Voice okay, sir.
Okay now? Na question amma?
Yes, sir.
So, for example, here I am going to taking a 3 ohm resistor is a load resistor. That is, in this 3 ohms resistor, I want to calculating the this 3 ohms resistor. I want to calculate the current of this 3 ohms resistor. So this is I am taking the load. Okay, up to now all of understand? Reply me, please.
Yes, sir. Yes, sir.
In Thevenin's theorem, replace this total. So remove this 3 ohms resistor first of all. So I am going to be, this is I am taking RL now, load resistor. So I am going to be removing that one. Removing that one. After that one, calculate the first case is RTH. So R equivalent, Thevenin's equivalent. For that one, you have to maintain the one property. That is, if you calculating the RTH by seeing this one, the source voltage, if the source will be R, if anyone will be there, anyone will be the source voltage will be there. So the voltage sources will be short circuit. The voltage sources will be short circuit. So this one is going to be short circuiting. So first to remove this one. After that one, by seeing in this way, you have to calculate the RTH value. You have to calculate the RTH value. This is your circuit diagram. So here the voltage source is going to be short circuited. The voltage source is going to be short circuited. So calculate the RTH from here. So what happened? This 4 and 5 ohms. Anybody tell me? me. Boys.
Parallel, sir. Parallel.
Parallel. So 5, 4 is parallel. So 4 into 5 by 4 plus 5. That value will be 2.2 ohms. Again, this one is going to be series with the 2 ohms resistor. So RTH will be coming to as 4.22. 4.22. Okay. 4.22. మహేష్ ఇక్కడ దీని రానికి ఏది తీసుకోవాలి
కలర్ ఏదో చూసేస్తా
Okay, so these two resistors are will be parallel. So what happened this one? 4
slideshow లో పెట్టాలి అట్లా రాయకూడదు.
Okay.
ఇది మ్యాక్సిమం కొట్టు ఇట్లకి
వైట్ బోర్డ్ అది మీరు పెట్టింది అది క్లోజ్
పీపీటీ
PPT.
వైట్ బోర్డ్
లేకుంటే
వైట్ బోర్డ్ క్లోజ్
ఏడాది
చూద్దా
మ్యాక్సిమస్ ఇంకోసారి టాస్క్
బ్యాక్ వెళ్ళిపోను నాకు ఎక్స్పీరియన్స్ ప్రాబ్లం
వైట్ బోర్డ్ నేను చెప్తా.
అవసరం లేదు నేను చెప్తా పీపీలు అడిగి ఇప్పుడు పాసిబుల్ ఉంది. ఓకే స్టూడెంట్స్, this is your circuit. In this one I am taking the 3 ohms is the load resistor. Three ohms is the load resistor. So I am going to be removing this 3 ohms resistor. Babu, play nama. Okay na? Babu.
Yes, sir. Yes, sir.
Yes, sir.
Okay, I am going to remove this 3 ohms resistor. In this next slide, see this one. In this next slide, so I am removing this 3 ohms resistor. After that one, I am calculating the second point is RTH. How can you calculate the RTH? Is removing this load resistor. After that one, voltage sources will be short circuited here. Voltage sources will be short circuited. See in this previous diagram, here 20 volts will be there. So this 20 volts is going to be short circuited. So by saying this way, you have to calculate the RTH value. I am going to be saying this way. So 4 ohms and 5 ohms are in parallel. That value will be 2.22 ohms. So this 2.22 is series with the 2 ohms resistor. So RTH will be 4.22 ohms. So this is our RTH value 4.22 ohms. So here I am replacing here 4.22 ohms. Here I am replacing here 4.22 ohms. So this total resistance part will be, this total resistance will be coming to as 4.22 ohms. After that one, I am going for VTH calculation. VTH calculation nothing but open source voltage or Thevenin's voltage. So for that one, again from seeing this way, I am calculating the VTH value. That VTH or VOC. So in this case, what happened here? Open circuit. So there is no current passing through this one. So this one is negligible. So this one is negligible. Here current is 0. Why? Because it is open circuited. So the current is 0. So this resistor is not useful for your calculation. So what is the voltage across this one is equal to the voltage across this one also same. So I am applying here This is single loop is coming to a single loop. So what is the equivalent resistance of this one? 5 plus 4 is 9. So what is the current across this one? I equal to 20 by 5 plus 4, 9. So I equal to 2.24. So the current flowing this resistor is 2.24 current. So the 2.24 current is multiplied with 5 ohms. We are getting the voltage across the this resistor. That is nothing but VTH. Voltage across the open circuit voltage. That is nothing but open circuit voltage we are getting coming. After that one, the Thevenin theorem equivalent circuit diagram is this VTH is going to be connected with the RTH. We are calculating the previous RTH value, that is 4.22. This total is part is going to be connected with the load resistor 3 ohms resistor. Load resistor 3 ohms resistor. So here apply your single, it is a single loop. So what is our requirement? I want to calculate in here current I. Current I. I equal to what is the formula for this one? I equal to V by RTH plus RL. So 11.1111 by Y, 4.22 plus 3 ohms. This is your current across the 3 ohms resistor. All of understand? All of you?
Sir, how we have calculated VTH, sir?
Okay, once I am repeating. We have to calculate in the VTH. First, you have to remove this RL now. Removing. After that one. See, I'm going to be removing this load resistor. So what happened this one? It is VOC, open circuit voltage. Here open circuit voltage nothing but from here current is coming. After that one, the current is divided into 2 parts, here and here. What about this one? This is open. So there is no current passing through this one here. When the circuit is closed form, then only current is formed, flow. So it is open now. So this current, this here current is 0. So I am going to be neglecting this one. So I want to VOC here. So that is nothing but in this parallel circuits voltage will be same. Okay, this resistor is offset. Why? Because there is no current. So I want to calculate the VOC here. That is nothing but here also VOC is same. That is nothing but VTH. Okay, so I want to voltage across this resistor. So what is the formula for Ohm's law? V equal to IR. V equal to IR. We know R value 5 ohms. We know R value 5 ohms. Okay, we required current value here. So it is a single loop connection. Single loop connection. So how can you calculate the current across here? Two resistors, total resistors. I, what is the I formula? I equal to V by R. I equal to V by R. That is 20 by total resistors. The total resistance is this one. 4 plus 5. That is the value of current is 2.22. Okay. After continuing 2.22 value current, we have to multiply this one with the resistor 5 ohms resistor. We are getting the VTH here. That is open circuit voltage. This one here VTH is equal to the here open circuit voltage also will be same. Okay. All of understand? Once again I repeat.
Yes, sir.
All of understand? All of you. So after connecting this calculation of the VTH, you have to connect this VTH to RTH in series connection. In series connection. In previous slide, we have to calculate the RTH value, no? Here, RTH value. This is RTH value. You have to connect this RTH into series with the VTH. After this total circuit, you have to connect with the load. This load. This load, 3 ohms resistor load. So this is our circuit diagram. 3 ohms resistor load, RTH value, in VTH value. Remember, VTH is series with the RTH. Okay. So after that one, this is single loop connection. Single loop formation. So what is I value? I equal to VTH by RTH plus RL. So this is your required current value 1.538. Load current value. All of understand? Babu,
Yes,
all of
sir.
understand?
Yes, sir.
Yes.
Yes, sir.
Okay.
Yes, sir.
Same process, we are going for Norton's theorem. Same process, we are going for Norton's theorem. See this one. This is your regular Thevenin's theorem final diagram. It is any network equivalent of this one. Remember, in case of the Thevenin's theorem, VTH is series with the RTH. The total part is connected to the RL. Remember this one. Okay. Next one is I am going for Norton's theorem. Okay. PPT is okay, Nama? Wow, PPT is okay?
Yes, sir.
Okay. Coming for here. In case of the Norton's theorem, see, this is your previous diagram now. So I want to calculate in case of the Norton's theorem, first of all, Rn, where same as the RTH. Where same as the calculation part of the RTH is the same as for Rn also. Okay. Next, there we have to calculate the open circuit voltage. Here I am going to calculate the IN, short circuit current, IN value. And in case of the Thevenin's theorem, the VTH and RTH are in series connection. In case of the Norton's theorem, IN is parallel with the Rn and total part is parallel with the load resistor. Okay, total part is parallel with the load resistor. And one more is same as in case of the Rn, RS, if the voltage source is going to see, we have to short circuit. If the current source is going to be seeing, we have to make it open circuit. So coming for this one, this is your given circuit. Given circuit, I want to same current flowing through the 3 ohm resistor. Same. So the current of this 3 ohm resistor will be same as for the Norton's also. We can check it. Okay, we have to check it. The current across the 3 ohm resistor is same as for the Norton's also, Thevenin's also. First requirement is Rn. So go for the Rn. Same connection, same diagram. So remove the load resistor and remove the load resistor. Here I have to calculate in the Rn and the voltage source will be coming to as short circuited. See this one. I am going to be removing RL 3 ohms. I am going to be calculating the Rn value. Okay, for saying this one in this way. So what happened? 4 and 5 is parallel. It is 2.22. Series with 2. So Rn will be same as for RTH. 4.22. Okay. Next, what is the next one parameter? What is the next parameter? Tell me. Babu, what is the next? What is the next parameter?
IN.
IN nothing but Norton's current, otherwise ISC, short circuit current across the low terminal. So remove this one low terminal. Okay, remove this one low terminal. I am removing that one and making one short line. This is your short line. Okay, this is one short line. After that one, calculate the IN value. So I am applying here mesh analysis. 2 meshes will be there. In the first mesh, it is clockwise direction. In second mesh, clock one direction. First one mesh current is I1. Second mesh current is I am taking as IN. It is same as IN now. Okay. So apply here. Apply the equations. So what happened? Here. So coming for first one, I am taking the first sign here. I am taking the first sign. So what happened? Minus 20. Okay. Plus minus. Here. Plus minus. Wait a minute. It is going to be arising. Mesh. There also. So minus 20. Okay. Erase it.
Erase it, no?
Erase it automatically.
Right, sir?
Okay. Here, I'm taking. Slides of which one? Okay. See here.
ఇది మ్యాక్సిమం చేసుకోండి. ఇది కనెక్ట్ చేసినావా?
పీపీటీ ఉండలేదు, పోతుంది. వస్తుంది. ఇప్పుడు వస్తుంది ఇట్లా దీంతో స్లైడ్ మొత్తం ఉంది. ఓకేమా? Here, see here, it is